Okay, again, so every process which is actively loaded in the memory has got the E process structure, right? Now, independent of the process itself is a part of a user space memory or the kernel space memory, the E process structure, which is the metadata structure for each process, will be part of the kernel memory. And E process has got the PEB, process environment block, which points to, which is having a field called LDR, right? So there is a pointer to PEB structure. This is a PEB structure. It has got the LDR field. This LDR field is pointing towards this 3 list from where LDR modules fetches the data. And these 3 lists are nothing but the linked list, right? Doubly linked list, which keeps track of the loaded DLLs into that particular process. So in order, in load order, it means it keeps track of the DLLs as it loads into the process memory. So that is why it is in load. Then in memory, keeps track of the DLLs as it find in the memory. So based on the memory locations or the memory addresses, right? And in initialize order means it keeps track of the DLLs based on the DLLs are initialized. So so ultimately all 3 lists should have the same number of DLLs loaded, right? But in a different order. And only exception is the exe itself will not be part of the init order list, because init keeps track of DLL based on the DLL's main function. Like, when DLL main function is called, it will be added into the init order list. But exe does not have init because it's a exe, it is not a DLL. So it does not have a DLL main function. So it will not get recorded into init order, init list. So basically that's why we don't see that, we saw true, false, true, right? That is for exe. So exe will not be part of the init list. So this is the structure we are going to refer, and we are going to use now our live debugging. So let me start. So I'm using LiveKD tool for kernel debugging. Live SysInternal tools, I talked about this in our first session. So this is, now I'm getting into the kernel level debugging, and now we'll start the processes. This is the command which we use for, so this is listing all the process which are already active in on my system rather. And we will pick up one of the processes from here, and then we'll go from there. Okay, so I just stopped it, but otherwise it will take long to complete the list. But we will pick up one of the processes. So this is the loaded processes right into the system, and we will take this everything.exe. Everything.exe, this is the loaded process, and this is the memory address where your E process for this this particular process is located, E process structure. So now I'm copying this memory, and we will enumerate the E process structure. So basically, if we go back to this diagram, this is the first step, E process. We are looking at the E process, okay, of a particular process. So D and T underscore E process is the structure which I would like to enumerate, and you go to this address and enumerate the E process structure. That's what we are saying. So this is the entire E process structure. We are not bothered about all the parameters here. I am bothered about, as of now, for the process environment block, right? So PC process control block, and there are many other things, active process links, which we saw last time, which has been used by PS list plugin of the volatility. But today we are going to talk about PEB. So we'll see where PEB is pointed, right? So let's not go entire list. We can just filter like this, -y PEB. So this is the memory address where PEB is located for this particular process. So every process has got process environment block. So we have taken the everything.exe and now we are enumerating the e-process structure. Now e-process structure is the metadata structure for the process, which is having the information related to that process. So if you see, I mean, you see this, all these fields, right? So these are nothing but the metadata about the process. What is a process control block and what is a word root and all that thing, right? Word count, what is process environment block, all those things. So this is the information about the process itself. So this is a metadata structure for process. And we are looking at the PEB now. So now we have got the PEB pointer. So now we will enumerate the PEB structure. Okay. To reach, and our ultimate goal is to identify the DLLs loaded into this, process. That is our goal. Okay. So all we are doing is we are reaching to that particular structure where I can find the DLL, how many DLLs are loaded, or like, at least to reach the head of that list, any of the list. So this is the PEB. Now let's enumerate the PEB. But before we enumerate the PEB, we need to set the context to that particular process. For setting the context to that process, you need to, this is how we set the context. So dot process, and then you have a e-process memory address. So now it will say, now we have set the context. Now we will say, okay, I want to enumerate this PEB. So DTNT underscore. Now I'm enumerating the PEB. So PEB is located at this address. Okay. So we'll take this, copy this address, and we'll put it here. And then this is the PEB. Now this is, we are enumerating the, where is it? Here. We are enumerating the PEB structure, and we are interested into the LDR. Within PEB, there is a field called LDR. I hope you can see this. LDR, which points to this 3 list. So let me see where LDR resides in the PEB. So simply again, I will use the filter function -y. I will say, tell me where the LDR is in this entire structure. It will say me, this is the pointer to this LDR data. So this structure is PEB LDR data. So I will enumerate this structure, and this LDR data should give me this structure, PEB LDR data, and it should contain this 3 list. So let's go there. DTNT. Now which structure we are enumerating? PEB underscore LDR dot underscore data, right? And which is the memory address where this data structure is located? Here, this is the address. The name of this structure is LDR, field name, but the data structure type is PEB LDR data. So we have to use that to enumerate the LDR, and we'll see here. Look at this 3 list we have now: in load, in memory, and in init, right? So these are the 3 lists as a part of a PEB for each process, and it has got the, I mean, this entry is the list. You have a list entry. So this list is not normal list. We have got the double linked list. So you have a forward link and backward link. So each entry of this list will point to the forward, I mean, next entry and the previous entry. So that is why it is a double linked list. Now we would imagine, like, this is the forward link. This is the first pointer. I'll go back to the diagram, and we'll see. Now we have got the in load order module list. Now, and the first entry of this is pointing towards the LDR data table entry. So if I want to enumerate this, I need to use this data structure, because the data structure residing on this particular memory address, which is pointed by in-load order module list, right? It is the LDR data table entry, right? So what I will do, I will take the first, this is the forward link, right? This is the forward link and this is the backward link, but we will go forward. This is the head of, I've got the head of the list, and this is the first entry. So I'll take the first memory location and I will say DTNT underscore now LDR data table entry. Why we are doing this? Because this is the structure which is residing at this location. So if I want to parse it properly, I have to tell the debugger, I have to tell the debugger use this structure to parse it, right? So that's why I'm giving this and at this memory location, and this will load the entire thing. And if you see here, the thing for for notice, we have got here full DLL name and base DLL name. So if you see here, this is the full path of exe and this is a short name, base DLL name. So you can see here we are enumerating the in load order module list. So in load means when it will keep track of the DLLs as it loads, as the process loads. So when process gets loaded, the first thing which is loaded into process memory is the exe itself, right? The executable itself for that particular process, and then the supporting DLLs are loaded. So always you will find the first entry of exe in a normal process, right? The first entry always for this list would be the exe itself, executable itself. And then if you see here, the next entry, now I need to know what is the next entry, right? This is the first entry of the list, exe itself. Now I need to know what is the next entry. So here you can see in load order list entry again, and this will be the next entry. So every structure has got the reference to the next structure and the previous structure. So this is the entry for the next structure and this is the entry for the previous structure. So let's enumerate the next thing, next entry. So you see here, this is anti-DLL.dll. So after exe is loaded, the next DLL that got loaded into the process memory was anti-DLL.dll. So this is the field from where your LDR module fetches the data. And if we want to go through the entire list, what we will do, we will simply use the list command and we will provide the memory address of the first address, head memory address of the first node in the list, which we have already seen, which is the exe. So list, so we'll use list -x. Then I will say what I want to see, I want to enumerate the LDR data table entry, and right now I'm just interested into full DLL name. Otherwise it will load entire structure. We don't need entire structure, we just need the full DLL name, because we are traversing through the entire list now. And then I will say from where to start. So I'll give not this one, otherwise it will start from the second anti-DLL DLL. The first one was this one, the first one, right? So this is the first entry, I believe. I will take this and I will say start from here and run through the entire list. That is what I'm saying here. So it should fetch all the DLL name, full DLL name, or other path to that DLLs which are loaded into the process's memory. So it will run through the entire list now. Let's see if I have typed it correct. See. So first is your everything.exe, right? So exe itself, then ntdll, then kernel 32 DLL, then kernel base, whatever. So now the entire list has been come up. So we have run through the entire list in load list. So typically any tool like Process Explorer or any other tool, EDR tool or whatever, like they use typically this in load memory list, sorry, in load module list for fetching the DLLs. Right, so if DLL is unlinked from this list, then it will not show up into those lists which are using this structure to fetch the DLL. Right, so that's how LDR module does it. So this is from one list we have seen. Now we will go for the next list, which is, okay, let's not go up and down. I will just list my PB LDR data again, and I'll have all three lists again. Okay, so let's go for LDR memory order module list. Now the important part which we need to understand here, like this list, right, in memory order module list, it points to the second field in mem order into the LDR data table entry structure. What does it mean? It means if you see here, in load order links, in memory order links, in initialize. So that in memory order list points to this particular field or this particular memory address, which is 10 hex address offset from the top of the entry. So if you see here in the diagram, so this is the offset, right? And then if I want to get the this name, because ultimately I need to get DLL full path of this particular structure, right? This is the field which I want to fetch. So if I want to fetch this thing, so I have to be on top of the structure. So if I want to be on top of the structure, I need to factor in the offset. So I need to reduce that offset minus the offset to reach on the top of the structure. So what we will do, now let's see, this is the memory address of in memory, right? And now same thing, we are enumerating the LDR data table entry, but if we go for this, we will not get the right now I'm not factoring in the offset, and I'm just saying give me full DLL field. So if you see here, everything.exe has come, which is not the correct field. It has to be full path. So it is not correctly mapping the field. So I need to reduce, I need to factor in, or I need to minus the 0x010, which is the offset, right? You understand, right? This is the offset we are reducing. So we are now reaching on top of the structure, and then we will say, okay, now give me DLL path. And why we have not done in the first in load order module, because it is pointing on top of the structure itself. So if you see here, in load order module is pointing on the in load order, so that is the top of the structure, so we don't need to reduce any offset. But if we are going for in mem order or in init order, then we have to reduce or we need to factor in the offset. We need to do that minus. So now if we do that, we have factor in the offset. We'll see now. Now if you see, we have got the full path, right? So this is how we need to do. And then again, now we will run through that entire list again. But just what we will do, we will give the top of the address again. And then we'll say, okay, this is the first address. I mean, this is the first structure, top of the first structure. So we need to provide the top of the first structure, and then we'll say, okay, now run through the entire list. Right, the same thing, but we just need to provide the offset. We need to keep, factoring in the offset into this. So then if we run this, so now we are running through the second list in memory. Right, the same thing. So you will find the way in which it has been loaded, it has been found in the memory as well in the same order. So we are just looking at the first 3, 4. The same order is there, like in load and in memory. It could be different in the the later on DLLs, but we don't know. But this is how you can run through the DLLs. So what we have seen, we have started with the everything.exe process. We identified the memory address for E process structure. Then we went to the PEB structure, right? Then we went to the LDR structure, and LDR is pointing towards these 3 lists. And then we have enumerated this all 3 lists using the LDR data table entry, and then we have traversed to the all the DLLs. So this is how LDR modules fetches the data from this 3 lists. Right, so we have gone through 2 lists. I'll keep third list for you guys, right? How to go or how to run through the the third list. So these are the 3 lists which we have seen in load, in memory, and in initialize. We have run through these 2 lists in load and in memory, and load and saw all the DLLs which is loaded as a part of this process. Right, so anything else? Yeah, this is the PEB LDR data. Right, I have not made this slide further because I just wanted to show this in a demo. So I will update the slides and share it across, but this is this is mainly for the demo purpose. Like, I mean, if you're not looking at the demo, if you're missing the demo, then there is no point of looking at this slide. The crux is the demo. So this is it, I think, for from my end. This is what I wanted to show today. You can contact me on this email, and obviously I'm available on LinkedIn. And yeah, this is what I think we have gone through today. LDR data modules and the this entries. I hope you guys have enjoyed it. And okay, all right, cool. I think Joanna is also there. Hi, Joanna. Okay, all right. You guys can connect me offline. Otherwise, I'm available on LinkedIn. All right, cool. Thank you, guys. See you next time. Thanks for your time. Bye.